Welcome back to the channel, Adventures Through Climate Change, with your host, me, Trevor, the only one that's ever on this video. Some of you guys know me actually from my other channels, but many you just are tuning in for the banter. What we do here is take an armchair approach to climate change, meaning we're just reading articles and watching videos and trying to figure out what the heck's going on. We're hitting all things climate change, and I apologize. My dogs are in my office right now, so they might be barking a little bit, but let's get into this. Today is Earth's magnetic North Pole is shifting south. So it's from Seeker. Oh, that's why the garbage truck's outside. You guys might be able to hear that. And we'll give them a like. And it's a real short video, so let's figure out what the heck's going on. Why is that right there? All right, here we go.
I have heard that Earth's magnetic poles tend to move around. I mean, so do the geographic poles, but magnetic north and south are really mobile. And magnetic north in particular is moving real fast, like way faster than we thought it would. And the scientific community is coming up with some really exciting and creative ways to figure out.
Sorry, I don't mean to stop it right away, but I heard that it's about Why is this giving me an echo right now? Hello, hello, hello. Echo? Did I hit something? Hello, hello. Okay, there we go. I had direct monitor something. Anyways, listen, I don't edit videos, so I apologize. But I heard that the polar shift is about 30 miles a year. I don't know. I read that somewhere. I could be completely wrong. Let's go.
Up with some really exciting and creative ways to figure out why. The prevailing theory about why our planet has a magnetic field in the first place is because of what's under the crust.
Right.
Dynamo theory, as it's called, is the idea that the molten metals of the outer core, like iron, are being convected, basically swirled, all around the Earth's interior, around that solid inner core. This continuously creates electric currents as charged particles move through this liquid metal, and in combination with the rotation of the Earth, it becomes what's called a dynamo, the source of a magnetic field. This also explains why the magnetic poles are not necessarily fixed points, because the liquid that creates that magnetic field is turbulent and always shifting, and the poles move as the fluid does. Right now, for instance, the North Magnetic Pole has been slipping down into Siberia for the past 150 years or so, and it's speeding up. Our magnetic field actually has a name. It's called the magnetosphere, and it plays a crucial role in making Earth a habitable planet. It wards off much of space's harmful radiation, like cosmic rays, acting like an essential protective cloak around the Earth, which is one reason why scientists and governments are so invested in knowing how it works and how it will behave, like the World Magnetic Model, for example. This huge and innovative computer model of Earth's magnetic field behavior is used by many international bodies as the guiding standard on what the world's magnetic field is up to. It combines sensor measurements of the field's strength and position, measurements which are then used in simulations of the geodynamo's past, present, and future behavior. The WMM releases updates to the model every 5 years, but in 2019 it was forced to release a mid-cycle update because magnetic north has been sauntering vaguely downwards much faster than anticipated. The perfect example of the fact that even though we're measuring and predicting to the best of our abilities, the geodynamo is too unpredictable and complex to make a truly complete model of it. That uncertainty means scientists are also looking for experimental ways to further probe the Earth's magnetic behavior, which typically involves creating models of the Earth out of liquid sodium, which is quite the commitment because sodium is a highly reactive metal that is extremely difficult to handle and likes to spontaneously burst into flame. New sodium ball experiments are being used in several labs worldwide, and in combination with improvements in computing and machine learning, could help us gain more insight into how Earth's magnetic field will change and how we can prepare for it when it does. Because what does a shifting magnetic field actually mean for us? Flipped poles would mean that the names of Earth's hemispheres may be a bit confused for a while, and compasses would point in the opposite direction than they did previously. But more importantly, as the poles shift around, the magnetosphere could get weaker, with several smaller magnetic poles popping up in other places around Earth. A weakened magnetosphere means many things. The northern lights will be visible in new parts of the world, for a start. And all our satellites would need to be extra fortified against radiation, or we risk them getting totally fried by space weather like solar wind. Electronics here on Earth would be extremely vulnerable to interference and destruction by space radiation too, like our power grids. And that's not even mentioning the human health effects of being exposed to much higher degrees of radiation from space, which, let me tell you, are not great. We know from studying magnetic inclusions that Earth's magnetic field has flipped entirely in the past. They trade places about every 300,000 years or so, but it's been over double that amount of time since the last time we know they flipped. So we are long overdue for some magnetic migration, and it's happening fast. And scientists are working hard to understand why and how they move and what exactly it may mean for us when they do. The next update to the WMM is expected in early 2020. Do you want to know more about it when it comes out? Let us know down in the comments below. Make sure you subscribe to Secret for all your science news, and for more on surprising things inside the planet, check out this video here.
Okay, so how do they know when the last polar flip was? And I guess it's kind of rhetorical. I feel like I know the answer, and because they say that it creates such a magnetic field that it wards off the radiation from the sun, correct? So they're measuring every time the Earth gets blasted by the sun by radiation. Because, you know, I mean, there was trees back then, and you can measure trees and stuff. You know, they supposedly they found a tree that was 500,000 years old that, well, maybe not that one, but there was something that held, that one had like a minor one where it went down. They could show where it went down to like very weak magnetic levels, but then it rebounded. Look, I don't know. I feel like us humans are so arrogant. Like we feel like we know everything, and then come 10, 20 years, we're like, I can't believe we believe that. And it's like, and then we revert back to the inventing the wheel again. I don't know. It seems as though I don't think we know as much as we think we know. And, you know, is that happening? Yeah. I mean, you can measure where the magnetic field is. I mean, and they can tell that it is speeding up because it was going, you know, 15, 20 miles per year. And now it's 30, you know, whatever. But most times that happens, it just rebounds back. You know, it rebounds back and then it kind of goes. But so I don't know. But these are the type of things when we talk about climate change that I'm far more interested in, because to me, this is climate change. Yes, I do think that there's like man-made climate change, but not to the extent that I think everybody else does. I do think that there are events on Earth, and we happen to be the most recent event, but there are events on Earth that happen on Earth, I should say, because meteor showers, volcanoes, whatever, that's climate change. This is climate change. Solar radiation, climate change. You know, I mean, it's because it's changing our whole climate, right? These are the type of things I wish we would put money towards learning a little bit better on what we can do or expect when these things happen. For me, you know, asteroids hitting the Earth, you know, meteor showers, major earthquakes and volcanoes, that type of stuff is what I'm more concerned about. And I mean, maybe we have a way. I mean, I used to work in the oil fields. I was in the fracking industry. And by fracking, it's fracturing, because you're fracturing the rock 10,000 feet below the ground. At least in the Bakken, we were 10,000 feet across. And I mean, you load these little charges, and they explode, and then they force sand and water down in there to fill the holes and stuff. So the oil, when they install a pump up top, it'll pump that oil out, and it'll have a funnel through those cracks that are filled with sand, because sand is obviously porous and the oil can get through with pressure. So then it says, so then we're taking that organic material that was, once alive. It was most oil is plant material that was, compressed with pressure and heat over time. That's turned it into fossil fuels. it's odd that we call them fossil fuels, but plants have fossils too, right? So is taking that oil out of the ground affecting any sort of, anything happen underneath the earth, the heat, the mantle? I don't know. Okay. I was responsible for helping pull some of that stuff out. And I think that, I'd do it again. I mean, I think we need to work towards other means, but I can't demonize how we've built up our society. Like, I'm not going to let other people starve because I have an idea that this might happen, So anyways, man, I talked a lot in this video for a 4.5 minute video that we shared watching together. I probably doubled that in talking. I know I did. So with that being said, maybe I earned your subscription. More importantly, I hope Seeker earned your subscription. Maybe we'll watch more of them. I hadn't been subscribed. And as always, like, comment, whatever. And I do hope to catch you on the next video.